Data modeling is the first step in the process of database design. This step is sometimes considered to be a high-level and abstract design phase, also referred to as conceptual design. The aim of this phase is to describe the data contained in the database, example, entities like students, lecturers, courses, subjects. The relationships between data items, example, students are supervised by lecturers, lecturers teach courses. The constraints on data, example, student number has exactly 8 digits. A subject has 4 or 6 units of credit only. In the second step, the data items, the relationships, and the constraints are all expressed using the concepts provided by the high-level data model. Because these concepts do not include the implementation details, the result of the data modeling process is a semi-formal representation of the database structure. This result is quite easy to understand, so it is used as a reference to make sure that all the user's requirements are met. The third step is database design. During this step, we might have two sub-steps, one called database logical design, which defines a database in a data model of a specific DBMS, and another called database physical design, which defines the internal database storage structure, file organization, or indexing techniques. These two substeps are database implementation and operations/user interfaces building steps. In the database design phases, data are represented using a certain data model. The data model is a collection of concepts or notations for describing data, data relationships, data semantics, and data constraints. Most data models also include a set of basic operations for manipulating data in the database. In this section, we will look at the database design process in terms of specificity. Just as any design starts at a high level and proceeds to an ever-increasing level of detail, so does database design. For example, when building a home, you start with how many bedrooms and bathrooms the home will have, whether it will be on one level or multiple levels, etc. The next step is to get an architect to design the home from a more structured perspective. This level gets more detailed with respect to actual room sizes, how the home will be wired, where the plumbing fixtures will be placed, etc. The last step is to hire a contractor to build the home. That's looking at the design from a high level of abstraction to an increasing level of detail. The database design is very much like that. It starts with users identifying the business rules, then the database designers and analysts create the database design, and then the database administrator implements the design using a DBMS. The following subsections summarize the models in order of decreasing level of abstraction. External models represent the user's view of the database and contain multiple different external views that are closely related to the real world as perceived by each user. Conceptual models provide flexible data structuring capabilities and present a community view. The logical structure of the entire database contain data stored in the database show relationships among data including constraints, semantic information such as business rules, security, and integrity information. Consider a database as a collection of entities or objects of various kinds that are the basis for identification and high-level description of main data objects. They avoid details which are database independent regardless of the database you will be using. And now let's talk about internal models. The three best-known models of this kind are the relational data model, the network data model, and the hierarchical data model. These internal models consider a database as a collection of fixed-size records that are closer to the physical level or file structure, a representation of the database as seen by the DBMS. It also requires the designer to match the conceptual model's characteristics and constraints to those of the selected implementation model. It also involves mapping the entities in the conceptual model to the tables in the relational model. Physical models are the physical representation of the database, and they have the lowest level of abstractions and are how the data is stored. They also deal with runtime performance, storage utilization and compression, file organization, and access methods. Data encryption are the physical level, managed by the operating system or OS. It also provides concepts that describe the details of how data are stored in the computer's memory. Data abstraction layer. In a pictorial view, you can see how the different models work together. Let's look at this from the highest level, the external model. The external model is the end user's view of the data. Typically, a database is an enterprise system that serves the needs of multiple departments. However, one department is not interested in seeing other departments' data. Example, the human resources or HR department does not care to view the sales department's data. Therefore, one user view will differ from another. The external model requires that the designer subdivide a set of requirements and constraints into functional modules that can be examined within the framework of their external models. Example, human resources versus sales. As a data designer, you need to understand all the data so that you can build an enterprise-wide database. Based on the needs of various departments, the conceptual model is the first model created. At this stage, the conceptual model is independent of both software and hardware. It does not depend on the DBMS software used to implement the model. It does not depend on the hardware used in the implementation of the model. Changes in either hardware or DBMS software have no effect on the database design at the conceptual level. Once a DBMS is selected, you can then implement it. This is the internal model. Here, you create all the tables, constraints, keys, rules, etc. This is often referred to as the logical design. The physical model is simply the way the data is stored on the disk. Each database vendor has its own way of storing the data. Now let's talk about schemas. A schema is an overall description of a database, and it is usually represented by the Entity Relationship Diagram, or ERD. There are many subschemas that represent external models, and thus display external views of the data. Following are a list of items to consider during the design process of a database. Let's talk about external schemas. First, you have your multiple subschemas. These display multiple external views of the data. Then you have your conceptual schema. There is only one. This schema includes data items, relationships, and constraints, all represented in an ERD. Then you have your physical schema. There is only one. Logical and physical data independence. Data independence refers to the immunity of user applications to changes made in the definition and organization of data. Data abstractions expose only those items that are important or pertinent to the user. Complexity is hidden from the database user. Data independence and operation independence together form the feature of data abstraction. There are two types of data independence, logical and physical. Let's first talk about logical data independence. A logical schema is a conceptual design of the database done on paper or a whiteboard, much like architectural drawings for a house. The ability to change the logical schema without changing the external schema or user view is called logical data independence. For example, the addition or removal of new entities, attributes, or relationships to this conceptual schema should be possible without having to change existing external schemas or rewrite existing application programs. In other words, changes to the logical schema, example, alterations to the structure of the database like adding a column or other tables, should not affect the function of the application, like external views. Physical data independence refers to the immunity of the internal model to changes in the physical model. The logical schema stays unchanged even though changes are made to file organization or storage structures, storage devices, or indexing strategy. Physical data independence deals with hiding the details of the storage structure from user applications. The applications should not be involved with these issues since there is no difference in the operation carried out against the data.